Yeah, this is not normal. I've augmented myself with a pair of eyes. Actually, in truth, it's more like a pair of ears. This is an ultrasonic sensor, distance sensor. It sends sound off one mic and bounces off an object and receives it from the other mic. And by measuring the time of flight, it will show how far away that object is. To be truthful, it's not me that I'm augmented this set of ears with, it's our house. So in some previous videos, I have shown how we've collected water from our little backyard creek down here and created some various water features. Like we have water coming at this top pond, it cascades down through 6 other ponds, and it goes back down to the creek. And then down there you can see we have 4 different fountains using the same water that we rediverted from the upstairs creek. I have some videos up here about some little more details on how we do those water features. So recently I rebuilt that upstream water collection pond, and so today I'm going to show you how I monitor the level in that pond and how we can control it with a set of valves. So hang on a second, I'm going to go into turbo mode and walk you up 100 feet to show you this pond. This is where the water is collected. It's a choke point in this creek. So this is a simple little plastic filter that acts as a sluice and keeps the rocks out of this pipe. And the water goes down this pipe, and this is the old collection pond. Not very big and get filled up with muck and it's hard to clean out. I actually have it mostly empty, but I wanted to show you how the plumbing works. So we have 2 pipes here. This upper pipe is an overflow pipe, and then there's a lower pipe down there, which is where the water feeds the lower fountains from. I created these simple filters out of chicken wire, wrapped it around a couple of PVC pipes, and like 3/8 inch chicken wire. And the lower filter has the same, but it also has a screen on the outside. Keeps the small particles out, keep the fountain nozzle from clogging. You can see here, those pipes lead back down into the creek. This is the overflow pipe, and this is the main pipe, and it feeds 2 ball valves. One controls the flow to the ponds, the other one controls the flow to the fountains. Ball valves are a little nicer than solenoids because we can turn them all the way on or all the way off or partially in between for better flow control. They're connected up to a Wi-Fi connected Raspberry Pi in this waterproof ammo box. So that Raspberry Pi also is what monitors the ultrasonic sensor. The little blue wire here snakes up to the ultrasonic sensor, which is underneath that plastic lid. Initially I did not have that, and when it would rain, the rain would splatter up onto the sensor and just took a little bit of water onto that metal microphone grill and give inaccurate readings. Speaking of inaccurate readings, this is what I initially had tried. This is a fancy laser sensor. Similar range and accuracy to the ultrasonic sensor, but it uses laser light instead of sound waves. As you might expect, had problems with water. It worked great when I would bounce it off of a solid object like the ground, but with water it would give inconsistent readings. Well, let's wrap this up. I'll go inside and quickly show you a little bit of code. This is the Python script that runs on that Raspberry Pi. It does multiple things, including controlling the relays that control those ball valves, and it has various sensors for measuring water turbidity and flow. But the one we're going to look at here is the US 100 ultrasonic sensor. So here's where we set up the object for that sensor using the Adafruit libraries. And down here is where you can see every 15 seconds we're going to take a reading. It's as simple as this for getting the temperature and this for getting the distance. This part of the code will normalize the distance from inches to 0% when it's empty to 100% when it's full. Then we publish that data to MQTT topic of creek level. I'll switch to Node Red here. In this green section of code, we can see how we monitor that water level. It picks up on that MQTT topic. This is a clever little filter that will, if the incoming data is a glitch, say a leaf fell down or something caused that sensor to misread, we'll ignore the value if it's greater than 2% of the previous reading. Every 15 seconds, it shouldn't change more than 2%. This is the main code. This is a function call, and where we get the status of the valves in addition to the level from the MQTT topic. And based on both what the valve status is and what the level is, we will either leave the valves alone or we'll increase them or decrease them to try to keep that pond 100% full. In addition to doing the valve control, we output data to InfluxDB, which then allows us to plot the data using Grafana. I'll show that in a minute, but before we get there, I can quickly show you other parts of this Node Red code. This is the yellow section is what controls the valves, either from Node Red dashboard commands or Home Assistant or voice commands, and that's done through an output to a different MQTT topic. So this red section demonstrates how we set up watchdogs for most of my sensors. The Python script will send out a heartbeat, which then goes to a watchdog code, and if that watchdog code senses for a specific amount of time, say 15 minutes, doesn't detect that heartbeat within 15 minutes, it will come back to this section of code and reboot that Raspberry Pi through a system call. So this is an example of that Grafana plot at the top, along with a time lapse showing the creek emptying. I closed off the incoming water and opened the valves wide up, and you can see the plot showing it going from 100% down to 0%. And then we closed the valves up and opened up the incoming water again, and you can see it refilling in about 40 minutes to 100% again. This is a plot that shows the creek level on this top line. Initially it's empty, and we've closed the valves off, and it fills up again in about 40 minutes. And these bottom two lines show the status of the two valves. So here we open up after the pond fills up to 100%, that Node Red code senses that, and it starts to squeak open those valves. First valve 1 to 10%, then both valves to 10%, then valve 1 to 20%, and so on. You can see as it does that, the level starts to decrease until finally we hit about this, when the valves are open to 40%, the level gets below a 90% threshold, and we start closing the valves again until we see the level start to go up again. And this way, when the creek starts to run dry, we can keep the pond at a good level, and we can prioritize valve 1, which feeds the fish ponds, and keep our little fishies alive. So this new pond, coupled with this ultrasonic sensor and new plumbing, seems to be pretty reliable. So I can probably stop pestering you with updated water exploits. If you have any questions, feel free to comment or shoot me an email. Thanks for watching.
Ellen is at UAB Hospital.